Hello everyone, hope you all are doing well. So in this video, we'll discuss the last problem of Leetcode Weekly Contest 371. It's a hard level problem. And actually the problem statement is exactly same of what we have for the first problem of the same contest. It's just the constraints that has made this problem tough. And it's a very good problem to solve. We'll see why, because it involves a number of concepts. So yeah, let's start. Okay. So the problem name is maximum strong pair XOR2. That was XOR1, okay? So you are given a zero indexed integer array nums. Now a pair of integers x and y is called strong pair if it satisfies the following condition. What is that condition? This one. That mod of x minus y is less than equals to minimum of x comma y. Don't worry, we'll come back to this, okay? We'll try to expand it and simplify this formula. Now what do you need to do? You need to select two integers from nums such that they form a strong pair and their bitwise XOR is the maximum among all strong pairs in the array. Okay. Return the maximum XOR value out of all possible strong pairs in the array nums. Note that you can pick the same integer twice to form a pair. Okay. So this is what the problem statement is. Now, before solving this exact problem, let's solve an easier version of this one. What will be an easier version? Forget about these conditions, okay? Suppose we are given an array, okay? Suppose we are given an array, what we have to do? We have to find the maximum XOR that we can get of two elements in that array, okay? Simple version, let's solve it first. So, I'll show you. Suppose I have an array, okay? I'll take some random elements. For example, let's take 1, 2, 3, 4, 5. Okay, these are the 5 elements I have. So this concept basically is how you approach the problems where you have to find maximum XOR or maximum or something like that. Whenever you have to deal with bits, and you know the constraints make it tough, you basically use this concept. Okay, so I'll just tell you. So suppose I have some numbers in my array. Okay, now what I do, I try to represent this firstly in binary format. Why in binary format? Because I have to find maximum XOR. Okay, I have to find the maximum XOR that I can get if I pick any two elements in this array. Okay, now ultimately I'll have to deal with bits. So what we do, we basically represent all these numbers in binary format and basically save it in a trie. Okay, basically save in a trie. It's just a special form of tree. So how do we do that? So assume that I convert every number into 3 bits. Okay, obviously you can have more bits, like for example an integer is 32 bits. Okay, so ideally internally an integer will have 32 bits, but all the bits will be 0. It's just that I'm concerned with last 3 bits. So for example, this is 101, this is 100, this is actually 011, 010 and 001, right? Right now consider only these bits. Okay, now what we do in these cases, let's first come to how do we store this. Okay, so if you talk about this guy, so 001, this is the least significant bit and this is the most significant bit. Remember, I am assuming that all my numbers are 3 bits. Okay, internally, yes, for integers that will be 32 bits, but I'm assuming those to be 3 bits to make things simple. And also since all the bits are 0 beyond this, no need to consider it. Okay, so what I do, I store it in a trie. How do I store it? So there is a node, there is a parent node, right? So in a normal tree, what do you have? You have a node, you have a left child, you have a right child. Okay, here what happens, you have a node. Okay, and then if let me just show you, if you want to store 001, so what will happen? These are binary numbers. That means every digit can have only two possible values, either 0 or 1. All right, because either 0 or 1, right? So what happens, I want to store 001, so that means the first bit is 0. Okay, so this guy can have only two possible children. If the current bit is 0, so the 0th child will basically point to a node. Remember, there is no data stored in this node. Okay, there is no data. It's just that this link tells me that, okay, there is a child node and this basically is 0. Okay, similarly this node can have two possible child nodes. Either it can have a child node for 0 or it can have a child node for 1. Assume it to be an array of 2. Okay, array of 2, where array of 0 says that this will point to a node if 0 bit is there, and it will point to an array of 1 will point to a node if 1 is there. This will become clear. Okay, so now the next bit is also 0, so this node will also point to a node. And what will be the link? The link will be 0. So the structure of a node will be like this: trie node, assume it to be trie, okay? Trie node, and in this what happens? You have node left and right, right? In a normal tree. Here what you'll have? You'll have trie node array of 2. Simple. You can have more data. I'm just making things simple. Array of 2. So array of 1 represents, sorry, array of 0 and array of 1. These are the two indices. Now array of 0 will tell you that, look, if this is not null, that means I have at least a number which has a 0 bit at this position. Okay. Now the last one is 1. So just assume that this is the node. Okay. This is how you store 0, 0, 1. Now let's store 2. So what is this? Is 0, 1, 0. So what happens at the first position? I have 0. Is there a 0 node? Yes. At the next position I have a 1. Do I have a 1 here? No. So create a node here. This is for 1. Do I have a 0? No. Create a node here. Okay. So just see, there are two different paths. Okay. There are two different paths. One is 0, 0, 1. Let me show you. 0, 0, 1. And then 1 is 0, 1, 0. Now let's store further numbers. Suppose I want to store 3. Okay. I'll just show you. So just a second. Yeah. So suppose I want to store 3. So this is the number I want to store. Let me just choose this one. Let me just come back to this. Okay, yeah. I want to store 3. So 3, 0, 1, 1. So at this position I have a 0. I start from the root node, right? Then the next position I have a 1. Yes, you have a 1. Great. Next position again I have a 1. Do I have a 1? No. Create a node. Next is 4. It is 1, 0, 0. At the first position, do I have a child for 1? No. Create a node. Then next is 0. And then next is again 0. This is how trie looks like. Then next is 5. So this is 1. This is 0. And here also you'll have 1. Okay. So this is how you store the numbers. This is all about how to store the numbers in a trie, right? Now comes the question, how to find the maximum XOR, right? So now let's just see, right? So first thing, what will be the maximum XOR, right? What will be the maximum XOR? So suppose element number 5, let me just show you. So the pairs are 1, 1, 2, 1, 3, 1, 4, 1, 5, then 2, 3, 2, 4, 2, 5, then it is 3, 4, 3, 5, then it is 4, 5. These are the pairs, right? For this one it will be, so 1 is 0, 0, 1. This is 0, 1, 0. So XOR will be 3. Similarly for 3 it will be 2. Right? 3 and 1. For 4 it will be, this is 4 and this is 1. Right? So this will be 5. 5 is, for 5 it will be, this is 1, 0, 0. So this comes out to be 4. So till now this is the maximum XOR. What about 2 and 3? Actually these are basically 3 positions. So if all the 3 bits are set, that's the maximum possible value you can get, right? 2 is this one, 0, 1, 0, and 3 is 0, 1, 1. 0, 0, 1. You get 1 here. 4 is basically you get 6. For 5, now just see, for 5 you get the maximum XOR, and that is 7. No need to count further, but this is how you get. So the maximum possible value you can get is 7. So ideally my answer should be 2 XOR 5. That is 7, right? So now what we do, suppose there are some elements like A, B, C, D, right? So the technique here is you add this number in a trie. Okay, you have added it. Then when you go to this number, or rather consider any position, suppose I consider this number, right? Now what happens when I consider this number? I want to find what is the maximum XOR I can get when I take XOR of C with any of the previously entered number, with any of the numbers on its left hand side. Okay. Now some of you may ask that what happens if my answer actually is C or D? That will also be taken care. When you come to D, actually A, B, C are there in the trie. So C or D will always be there. Okay. So now the technique here is when you come to C, A and B are already in the trie. So what we do, we just check what is the maximum possible value of XOR I can get when I take XOR of C with any of the already entered numbers, right? Now comes the question, how do I find the maximum XOR? So just see here. I'll just show you. So let's insert some values. So these were the values that we inserted, right? These were the values. Let me just copy the tree. It's not that clean, I know that. but I'll just change the page. This was the tree that we had, right? And let me just write the numbers. Let's change the color. So this was 1, this was 2, this was 3, this was 4, this was 5, right? This is what the numbers were. Now actually what will happen, I will remove some nodes. So that means, suppose I just remove these numbers. Let's assume I have only inserted till now 1 and 2. Okay, and remove 3 as well, right? Remove 3 as well. Now the next number I want to insert is 3. But before inserting 3, I just have to check that what's the maximum XOR I can get. So if the numbers that I have is 1, 2, 3, so assume 1 and 2 I have inserted. Now when I come to 3, I want to find the maximum XOR I can get when I take XOR of this 3 with any of the previously entered numbers, right? So what I do, the binary representation of 3 is 0, 1, 1, right? Now to get the maximum XOR, remember that I've stored the numbers like this. So this is MSB, this is LSB. So ideally I would want the first position to have a 1, right? Any position on the left hand side, any bit on the left hand side has more weightage than combined sum of all the bits on its right hand side. That is why it is known as MSB, right? So my first aim is to, in the answer, in the XOR, let's make it 1. Now how do I make it 1? 3 has 0 at this position, so I should choose a number with 1. So what I do, I start traversing my trie and I just see, do I have any number with 1 at this position? If I have it, obviously I'll pick that number. Obviously there can be multiple numbers, so I'll go at this path, but do I have it or not, right? So in this case, what happens? This is 0. There is no child with 1. So that means no, there is no child. So the only option I have is go to this path. That means come here. Okay, great. So at the first position, I was not able to get a 1 in my answer. What's the next bit in 3? It is 1. Now in answer to get 1, I should ideally select a number whose this bit is 0, right? Because 1s or 0 will give me 1, right? So this is 1. I want 1 in my answer. So I should have a 0 at this position. Now I'm standing here. Do I have a number which has 0 at this position? Yes, you have a number. So you go in this direction. Simple. Oh, great. So I'll go in this direction. Now what's the next bit? This is 1. Again, to have 1 in my final answer at this position, I should choose a number with 0 here, right? Let's choose. Do I have a number with 0? No, you do not have a number with 0. So you're bound to choose this number. Okay. So what have you chosen? 0, 0, 1. If you take XOR of 3, what do you get? 0, 1, 0. Maximum XOR you can get is 2. Now we have only inserted 2 numbers till now, right? Now let's verify that if we would have taken XOR of 3 and 2, my result would have been different. It would have been less than this number. So what is 2? This is this. And what is 3? It is this. So 0, 0, 1. Just see. So the maximum XOR you can get when you take 3 and a number inserted on the left hand side of 3, that is 2 only. Okay. Simple, right? Now you insert 3 as well. Now you move to 4. Now 4 you can get when you 4 and a number on its left hand side, right? I know it's a very long video. Reason being, it involves a number of concepts. First, how do you represent numbers in form of trie? Second thing is how you find the maximum XOR. Now comes our main question. So the main question was, I do not have to just find the maximum XOR. Rather, what I have to do, I have to also find this. I have to also satisfy this condition. Now, what is this condition? Mod of x minus y is less than equals to min of minimum of x5, right? Let me write it. This is the condition. It is less than equals to minimum of x comma y. Now, let's assume x is greater than equals to y. X is larger. Obviously, one number will be larger or equal to, right? So what happens in this case? It becomes x minus y is less than equals to y. Right? This condition has to be satisfied because x is large. So minimum of x comma y will be y. And you open the mod, it is x minus y only. Now this becomes like this. Right? So this condition has to be satisfied. This condition. In other words, if this is the condition, this is against me. This is what I want. That means I should choose the number such that the larger number is less than equals to twice the smaller number that you choose, right? That's the only condition. Now in a trie, we need to take care of that. That's the main thing, right? So what we will do, it's very simple. It's very simple. Now all we need to do, we have seen how to add numbers in trie. how to find the maximum ZOR, the only thing we need to see is how to delete in trie. Okay, how to do deletion in trie. So deletion in trie, again, there are multiple ways to do that. I will tell you just a simple way. A simple way here is what I have also done in the solution to make it easy, right? So as I told, in a node I have two child nodes, right? One for 0, one for 1, right? So it's basically node or trie node of, it is children, right? Like this. I also have taken an integer array of 2. This basically stores the count. That means for a particular node, how many numbers are there? Okay, how many numbers are there which has gone through this path? For example, every node can have two paths. One goes via 0, one goes via 1. So this node keeps a track of how many numbers go via me which has 0 at this position. Okay, I store the count here. How many numbers go via me which has 1 at this position, I go via this, right? So instead of having just these two nodes, I also store it. For example, let me show you a concrete example. This is the parent node. Suppose I insert what do you call it, simple, suppose I insert 1. So it is 0 0 1, right? So what I'll do, this is 0. Now count of 0 will become 1 and count of 1 will remain 0 only. There is one number, okay, there is one number which passes through this node having 0. Then what the next node, again that is 0. Awesome. So 0. So for this also there is one number 0 at this position, none. And then for the last one you have 1. Okay, simple, you have 1. So this guy will have no zeros, rather you have a 1 passing through it. Now if I want to add 2, what will happen? This is 0 1 0. So 0 remains like this. Count increases. Okay, two numbers have 0 at this position. Next is 1. So you add 1 here. And for this guy, 0 zeros pass through it and 1 1 passes through it. The next is 0. Now for this, number of zeros is 1, number of 1 is 0. Okay, this is basically key, this is basically value. Getting it? This is what I do. Now when I delete a number, suppose I want to delete 1 from this number. Okay, so what I'll do, I'll again start from here. I want to delete this one, right? So I'll simply decrement the count. Meaning, initially there were two numbers which were passing through it, but now there is only one number passing through it. Then I go to this path, because the next is 1, right? I go to this path. Now what I do, again I decrement the count of 1, because this is for 1, right? It becomes 0. Then I go to this, I again decrement the count. Okay, this is what I need to do. Now obviously I need to take care of this condition. I'll show you how we take care of this condition, but ultimately, so basically now I know how to add numbers, now I know how to delete the numbers, right? You can simply update these counters. Now when you want to find the maximum XOR, I showed you how to find the maximum XOR, right? If there is a 1, I want 1 in my answer, you pick a number with 0. Now all you need to do is you also need to check the count, that the path where I am going. Suppose I have a 1 in my answer, also I want a 1 at this position, so I should select a 0. But if I'm standing at this node, I'll check that, okay, I want a 0, but is there a 0? Is there a 0? That means, is the count of 0 more than 1 or not? Remember, 0 is there, but is the count of 0 more than 1 or not? Because the count of 0 tells me how many numbers have 0 at this position which are passing through it and are still there in the trie. Maybe initially there were some numbers, but now they have been deleted. Because of this only, these nodes are there, but ultimately their count has been removed. Okay, so that is what we do. This is the only extra condition we need to add, right? And we will be done. Okay, so now if I come back to this question, enough of theory. If I come back to this question, we need to satisfy this condition, and we also know how to find the maximum XOR now, right? So now here what we'll do, we only need to pick two numbers. The order of numbers doesn't matter. Okay, and also I also showed you that the condition here is the larger number should be less than equals to twice of this, right? Now if I can somehow order my numbers, right? If I can somehow order my numbers, I can use a sliding window technique. For example, if this is the array, suppose I'm standing here, this is the larger number. Okay, this is the larger number. X has to be less than equals to twice of y. Or I can say, as soon as x becomes more than twice of y. So there is a large number x, there is a small number y. Okay, Now what happens? These are my valid numbers. When these will be my valid numbers? Till x is less than equals to twice of y, right? X is less than equals to twice of y. When these are satisfying your condition, what do? You basically have these numbers in your trie. Now what you do? You move one position on the right hand side. You say, look, this was the latest number that I inserted, right? You remember how the first step that I showed you, how to find the XOR. Now the next number I insert, suppose now this is my x. Now the y is same. Now what has happened? Your x has increased. Your x has increased. Now ideally x should be less than equals to twice of y. But y is same. So there are chances this condition has been violated. So you also need to increase your y, right? You also need to increase your y. You have increased the value of x, you also need to increase the value of y, then only this condition will be satisfied, right? So what do? You simply use a sliding window technique. If this y is not satisfying this condition, you remove this from the trie. Now you check for next value. If this y is also not satisfying the condition, you just remove it from the trie. So it's a sliding window technique. Every node will be processed at most twice. Okay. So here, if you just come, I'll just show you what I've done. Okay. Examples are self-explanatory. Also, the code may look a little bit big, but it is exactly what I've explained you. And trust me, this is all boilerplate code. Okay. This is how code of trie looks like. Let's go step by step and this will become crystal clear. Okay. Now just see, this is the structure of trie node. Okay, I have two child nodes, one for 0 and one for 1, and this is the count. I'll have two counts, right? How many nodes have 0 at this position and how many numbers basically have 1 at this position, which are still there in the trie. Okay, this is the root node of the trie. Now this is the main function. Answer equals to 0. I sort the numbers. Why I sort the numbers? Because I have to satisfy the condition given in the problem, right? Then what happens? This is the number, this is left, this is right. Just simple two-pointer approach, right? Now I insert a number. Assume it to be x, right? Nums of right is inserted. Now what happens? While twice of nums of left is less than nums of right, right? My condition has to be larger number should be less than equals to twice of y. This says that if twice of y is less than x, that means just opposite of this. So what you need to do? You need to increase your y. So what I have done? Delete the current y from the trie, because the array is like this. This is left, this is right. So this is acting as x, this is acting as y. So you remove this number from the trie and move to the next number and check it. Is it satisfying the condition or violating it? So that is why it's a while loop. While this condition is not in our favor, okay, you keep on deleting the numbers from the trie because these numbers are already added. I am standing at this number. These numbers are already there in the trie, so just remove it so that you are left with only valid numbers that satisfy, this condition. Okay, done. Now what you do? Answer equals to math.max of answer and this function maxor. This is the number that you are inserting, right? This is the number. So for this number, just find the maximum XOR with all the existing numbers in the trie and return the answer, right? This is what the code template looks like. Now comes the question, how to insert the numbers, how to delete and how to find the maximum XOR. So let's first go to the insert part. Now in the question, it says that the numbers are of 20 bits, okay? In the example, I said that I'll consider all the numbers at 3 bits just for the sake of explanation. So these numbers are 20 bits. So what I'll do? I'll consider all the numbers to be of 20 bits. So we are inserting the numbers from MSB to LSB. So even if you have 1, the parent node will have 0, 0, 0, 0, 0, 0, 0. At 19th level, you have a 1. So this is why this is how 1 is represented, okay? Now find the index. So num right shift I and 1. This is how you find whether a particular bit is set or not, right? Simple basic stuff. Node.children of idx equals to null. That means if this is the first node, for example, you start from here. If you are inserting the first number, there is no node for 0, no node for 1, everything is empty. So if this is null, you create a new node and basically make the 0th child points to this. Similarly, if 1 is null, you want it, create a new node, make the 0th child point to it. And if the node is already existing, simply move here. No need to create a new node. So that is what we are doing. If it is null, create a new node, okay, and then move to that node. Simple. If no need to create, then simply move it. And node.count of idx plus plus, meaning if this is 0, so one more number is passing through it, which has 0 at this position. Simple. This is basically to represent deletion. Okay. Now let's come to delete. Exactly the same code. all you need to do is just decrement the count. Here you are increasing the count, here you are decreasing the count. The traversal thing is exactly same. Okay, it's very simple. Actually, try is very simple. Now comes the question, how to find the maximum XOR. So again, you start with root. Initially XOR is 0. This is the weightage of the current bit, right? So you just check what is actually the current bit, right? Whatever number I am inserting, this, suppose this is the number, consider this bit. What is the current bit? If it is 1, I want to select a number in the trie which has 0. So this is the current number. What is the required number? B. So again, if it is 1, you need 0. If it is 0, you need 1. So that's why we use this formula 1 minus a. You can also take XOR with a, both works, right? XOR with 1, both works. But ultimately, this is the current number and this is what I want. And this is the bit I want, right? Now, I just check. If node.count of b, that means whatever is the required bit, if its count is not equals to 0, that means there is still a number, right, with the required bit. So what I do? XOR equals to XOR or current. What's the current number? This. You can replace it with 1 left shift I. Both works. I was just trying out to improve time. That's why. And then node equals to node.children of b. You move to the next node. Simple. Okay. Now this condition is when whatever is the required bit that is present. Now, if the required bit is not present, so the only option you have is move to the same bit. For example, if you have a 0, you want 1 in your result, so you need a number with 1. But if there is no number in the trie which has 1 at this position, what you do? You move to the set of numbers which has 0, and you try to get the best possible answer, right, for the next bit now, right? So else node equals to node of children dot a. Simple. Now these nodes will always exist. Reason being, whatever is the value of the number, I have considered all the numbers to be 20 bits. So ultimately there will be actually a node, right? That's it. And current this, right? So this basically can be replaced by this. So simply I start with 1 left shift 20, then for the next iteration it will become 1 left shift 19, 18 and so on, right? And finally we will just return the XOR, right? So I hope now you understand why actually it's a hard problem. Reason being, you should be familiar with tries. With tries this problem becomes very easy. It's just that even if this condition is removed, it's a good question, because deletion in trie, how you handle it is a little bit, I would say, cumbersome to code. Here we have just taken, the help of this counter. Generally, there is another way to delete it. You can take a stack as well if you actually want to delete these nodes to save some space. But again, that is not required here, right? And this is how you find the maximums also. The tricky part is just to take this count, using which you can just find the maximums all. Because I need to somehow identify that whichever node I want to go, is it actually existing in the trie, or is it for a number which has been deleted from the trie? Okay, so this is how you solve this problem. So yeah, that's it for this video. I hope you learn a number of new things in the video. So yeah, if you have any questions, mention that in the comment section. If you found this video useful, please do support it by giving a thumbs up. Do subscribe to the channel as well. If you have any other method in your mind, let me know in the comment section. Okay, so that we all can learn from each other. Okay, thank you. Take care. Bye bye.